today we'll be discussing about Ethernet cable overview. So any guys, you guys have any idea about Ethernet cables, about cables, what is cable? Anyone?
Physical connection.
Yeah. So it is a physical connection.
Yeah.
Yeah. Then any other people? What is cables? So has he told these are the physical connection? So I'll tell that Ethernet cables are networking cables. Ethernet cables are networking cables. Networking cables used to connect devices. Connect devices such as computers, comma, routers, comma, switches, comma, and hubs in a local area network. In a local area network. Local area is nothing but LAN network. And they are used to they are used to transmit they are used to transmit data between between devices using Ethernet protocol. And Ethernet is a family of technologies that provides layer 2 and layer 1 functionalities. Layer 2 is data link layer and layer 1 is a physical layer for controlling and access to shared network medium. And it is emerged as a dominant technology used in the networking, cabling and crimping. So you guys know what is cabling and crimping. I'll just show you one small video, then you'll get to know what is crimping. Sorry, crimping. So if you guys were in offline class, we could have shown all these things. But it's online class. Unfortunately, we cannot. You guys want to see everything virtually. So these are the materials needed.
Hey guys, all right, today we're gonna crimp an Ethernet cable. So first what you wanna do is you wanna remove the sheathing on the wire using the little handy dandy wire stripper. Pull that sheathing off. It's gonna expose the twisted pairs. It's gonna take a few minutes to separate each pair and then go ahead and untwist them and get all the wires nice and organized. Now, once you get them organized, there's a specific sequence in which they need to go in. You'll see the diagram come up on the right-hand side of your screen momentarily. Boom, there you go. All right, here comes the diagram. Excellent. All right, so now what you want to do is grab your FD 500R crimping tool and you want to cut off some of the excess wire because we don't need that much to go inside the connector. All right, grab one of your connectors and you want to funnel those wires inside, maintaining that specific color sequence, just like that. I like to insert mine a little bit more, make sure that some of the sheathing gets in there a little bit, makes it nice and clean. Okay, so next you want to grab the FD500R tool and you want to insert the connector into the top right slot. It clips in kind of like you'd clip it into a wall jack. All right, get that clipped inside. You'll hear a little click. Once you do that, you just want to squeeze the crimping tool closed. There we go. All right, now make sure you just go ahead and unclip it from the tool. And there you have it. Good to go. An Ethernet cable. Nicely crimped. Everything's available at www.farrellsdirect.com. Check the links below.
So is a crimp, how they do crimp in real time. So now Ethernet is going to use twisted pair. So in twisted pair cabling, a typical twisted pair cable consists of 8 wires. We will have 8 wires and it is divided into 4 pairs. These 8 wires, and each wire will have a specific color code. Each wire is going to have specific color code. I'll just show how. Then each wire will have a specific function. Each wire will have the specific function. And the process of attaching the RJ45, RJ means register jack, 45 jack with a cable, which we are attaching the RJ45 jack with the cable is called crimping, as I showed. Whatever the RJ45, that cable RJ45 with cable is called crimping. I show no that process is called crimping. And only 4 wires will be used to transmit information in Ethernet and fast Ethernet. We have Ethernet and fast Ethernet technology. So only 4 wires will be used to transmit the information. And from gigabit, we have gigabit Ethernet. It will use whole 8 wires in gigabit. So in case of Ethernet and fast Ethernet, only 4 wires. And there is a standard color code for connecting the jack. It is called TIA EIA 568B, the standard color code. So the color code is like, we have total 8 pins, as I told, 8 wires, sorry. A typical twisted pair cable is going to contain 8 wires and this is divided into 4 pairs. So we have here 8 wires. So first color code is orange white. You can see orange white. And second color code is orange. We can tell it orange white or white orange for first pin. And second pin color is orange, and third pin is green white, and fourth pin is blue, fifth pin is blue white, sixth pin is green, and seventh pin is brown white, and eighth pin is brown. So this is the color coding for connector 1 and connector 2 side. So normal color code, but we have types of cabling. So types of cabling is like straight through cable, crossover cable and rollover cable. You can see a rollover cable. So I'll just show the small, like if I tell just colors you'll not get to know. We'll just see one link. Okay, how to make Ethernet cable straight through and crossover.
This new Lenovo Yoga 7i laptop that is powered by the latest Intel 12th generation processor, 2.8K screen that we are getting.
Lenovo Pen 2, quick charging, all of those things make it really viable.
You just look at the difference between straight through and crossover, because if you were in the
Hello,
online class, we could have showed the.
and this is Sunny. Welcome back. Today my talk.
So if you guys were in real time class, like offline classes, we could have shown you guys the cables and differences. But now if I'm just telling theory part, you guys will not understand. So I'm trying to show in virtual manner.
Topic is straight through between a RG4
You can see the cables.
Ethernet UTP patch cable, also known as patch cord, is a form of Ethernet UTP cable with RG45 connectors on both ends. A UTP patch cable can be used to connect two electronic devices, such as connecting between a computer and a network port, between a patch panel to a switch, or between a switch and a router. A UTP patch cable is relatively short. An Ethernet patch cable can be as short as 3 inches long, and it can be 25 foot long. Most often, you will see 6 to 9 is made of more flexible and different in terms of
So
functions.
you can see here
The
straight through cable. This is straight through cable and this is crossover cable. So so you guys here you see I told about color codings. We have 8 pins here. So this is a color coding: orange, green, white, blue, white, green, brown, white, and brown. So this is the actual format. But in different types of cabling, we have straight through cable, crossover cable, and rollover cable. So why this straight through cable is used for? This straight through cable, it is used to connect different devices. So we from switch to PC, from switch to server, from switch to router, is used to connect to the different devices. But in case of crossover cable, it is used to connect to the same devices. Now I want to connect from router to router, from PC to PC, switch to switch. So in that case, I'll be using crossover cable. And in case of rollover cable, this rollover cable it is used for management purpose. Rollover cable it is used for management purpose, like configuring routers and switches. Like if you want to configure, we are going to use rollover cable. So first, we'll go to straight over cable. As I told, is used to connect to different devices. The same color code is used in both the ends. So here I gave color coding of orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. Same color codings is used in the both ends. If you want to connect to the different devices, we are using same pins in connector 1 and connector 2. Both the sides will be using same color codings in case of straight to cable. So here you can see here, like in straight through cable, both the ends green. See, both the ends are using same cable. See, green, this thing.
primary difference is UTP patch cable is terminated differently with RG45 connectors. A Type A straight-through cable has Type A RG45 connectors at both ends. Specifically, pin 1 on one end goes to pin 1 at the other end, and pin 2 to pin 2, pin 3 to pin 3, and so on. And that's why it's called straight-through. A Type A crossover cable is different. One end is Type A connector and the other end is Type B connector. Specifically, green and orange color are swapped. So Type B straight-through cable has Type B.
So as I told, in straight through cable, we'll be using both the ends, like connector 1, connector 2, it will be same color codings. You can refer this video if you guys want. So next, coming to crossover cable. Crossover cable I told is used to connect same type of devices. If it is like router to router, PC to PC, switch to switch. And in Ethernet cables, only 4 wires are used to transmit information. Two wires for sending, like pin 1 and 3, and 2 wires for receiving, 2 and 6. The remaining 4 wires are actually unused in Ethernet and fast Ethernet. But from gigabit Ethernet, all wires are used to transmit data. Here I told in the beginning itself. See, only 4 wires will be used to transmit information in case of Ethernet and fast Ethernet. But in case of gigabit Ethernet, they'll be using all the 8 wires. Same thing here. See, in Ethernet cable, only 4 wires are used to transmit information. 2 wires for sending, like 1 to 3. This green white you can see here. Green white. This is the third connector, third pin. Again, we have second one is orange. 2 to this pin 2 to 6 for receiving. For sending is 1 and 3, 1 and 3, and for receiving is 2 and 6. 6 is green. You can see here green. See here 6 is green. Sixth one. And but remaining 4 wires are actually unused in Ethernet and fast Ethernet. But from gigabit Ethernet, whole wires are used to transmit data. So this is the first end and this is the second end in case of crossover cables. So it will be from 1 to 3 and 2 to 6, 3 to 1, 4 to 4, 5 to 5, again 6 to 2, 7 to 7, and 8 to 8. These both will be same. Only these things are changed. These both will be same. Brown, white, brown, white, brown, brown. But in case of straight through cable, everything is same. Now coming to rollover cable. It is used for management purpose. Like example, like I told, we will be used the rollover cables in configuring routers and switches. And these rollover cables are used for configuring Cisco routers and switches as I told, and connected on console code of the Cisco devices in order to configure these things. And Cisco uses CLI. CLI means command line interface for configuration mostly. But Cisco can also use GUI. GUI means graphical user interface, but CLI is more stable when compared to GUI because GUI contains lot of bugs. So rollover cable, the pin will be exactly opposite. It will be like, see, 8 7 6 5 4 3 2 1. Here you see the order. 1 2 3 4 5 6 7 8. Exactly opposite to the. So this is exactly opposite. You can see 1 to 8, 2 to 7, 3 to 6, and 4 to 5, 5 to 4, 6 to 3, 2 to, sorry, 7 6 I told. Here it will come exactly, it will be opposite. 1 2 3, so 1 to 8, 2 to 7, 3 to 6, 4 to 5, 5 to 4, 6 to 3, 7 to 2, 8 to 1. This is exactly opposite. So these are the type of cables. This is just a basic thing you want to know, so that's the reason I just made it simple. So any doubts with the cables, types of cables? No doubts?
Mm.
Okay, it's simple, right?
Yes.
And you just want to know, you'll not get in your interviews and all related to this.
Ma'am,
Sorry.
ma'am, what is gigabit Ethernet?
So that is all interfaces: gigabit, Ethernet, fast Ethernet. All those will be the interfaces
Okay, ma'am, it is only used for local area network work, right?
with
This
gigabit.
cables, this cables, Ethernet cable.
No, I didn't get your question. Sorry.
It is only used for local area network, right?
Okay, this interfaces you're asking.
Cables, Ethernet cables.
Cables. Yeah, to the local area networks only.
Oh,
Like, yeah, because I mentioned in the beginning only, right? That
yes.
thing. Yeah.
What is in case of a wide area network?
Wide area network will be using internet, right?
Yeah.
Yeah,
For cables, Ethernet cables, what we
LAN,
use.
for LAN purpose, LAN, local area network.
Yeah.
Getting?
Ma'am, I'm
See,
asking
now
that.
you want to connect from India to US. Can you use cables?
No, that's what I'm asking.
Yeah, that's what I'm telling.
Yeah.
Okay,
Okay. Thank you.
fine. So next we'll go to IP, IPv4 addressing and subnetting. So any idea about IP address? Until anybody? What is IP address? So IP means Internet Protocol. Means Internet Protocol. So it is a logical address assigned by network administrator to each device in a network. This IP address is a unique identifier. I'll just tell the definition. What is exactly? So these are the IP address is the unique unique identifier. Unique identifier for devices devices on a network. So the two main functions are the two main functions are it will identify the host host or network interface network interface and to locate it in the network and to locate it in the network. So IP address is nothing but internet protocol. It is a logical address assigned by the network administrator. Network administrator is going to assign to identify each device in a network. Example, we have 100 routers. To each and every router, we will have unique IP address for identification purpose and for the communication purpose and for security purpose as well. And IP address is the unique identifier for the devices on the network. The main purpose of this IP address is it will identify the host or a network interface and locate it in the network. And every IP address will have two parts. One is network side and another will be host side. What is this network side? So network side means this is going to represent the network. Which network is this? And host side, it represents the host device, which is the host device. And in this IP address, there is a two version of IP address. First version is IP version 4 and second one is IP version 6. So in real time, mostly we'll be using IP version 4. Okay, fine. So there are two versions in IP address, that is IPv4 and IPv6. So IPv4, IP version 4, Internet Protocol version 4, and IP version 6, version 6. So this V4, it is a 32-bit address. So in this IPv4 address is decimal representation, and this IPv4 is divided into 4 sections, and each section contains 8 bits. I'll just show the example. The maximum address in IPv4 is 2 power 32. How we are getting 32 here? I will show you. So it is 4 billion address in IPv4. That is total 400 crore IPv4 address. So I'll show the example. Example. So I'll take example as 8.8 dot, or else I'll take as 1.1.1.1. So here each bit is having 8 bytes. Which time? Should I stop the class? I started 12:30. Okay. 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 So I told it is divided into 4 sections, and each section contain 8 bits. So here you see 1, 2, 3, 4. It is divided into 4 sections, and each section is having 8 bits. I'll just, how should I show this? So this one, hello, hello. After class I'll go. You told after class you come. 1:30. Mm, mm. So this bit is having 8 bytes, and this one is having, this one is having 8 bytes, and this one will have 8 bytes. Sorry, 8 bits. So coming down, you can see 8, 8, 8. So 8 plus 8 plus 8 plus 8. What is the value? Hmm? Answer, guys. What should I give?
32.
Huh?
32. 32.
32, right? See, total is 32. So I told you it's a 32-bit address. How 32-bit address? In this way, it is divided into 4 sections, and each section is going to have 8 bits. So 8 is 32-bit, and this IPv4 address is in decimal representation. It contains numbers only. See, I have taken numbers and I have represented in decimal format. And this is divided into 4 sections. You can see 1, 2, 3, 4 sections, and each section has 8 bits. So the maximum address of IPv4 is 2 power this. Total is 32. 32 is 4 billion, 4 billion address in IPv4. We have only 400 crores IPv4 address in version 4. Till here you guys are clear? Any doubt I can tell, because if you don't know this subnetting, then it's a waste. You cannot learn routers, switches and all, because you have to know IP address to configure all the routers, interfaces, everything, like default gateway and its subnet mask, all those things. Clear till here?
Yes.
Okay, fine. So now your each section each section contains 8 bits. Section contain 8 bits called, we call this as octets. Okay, this is about IPv4. Next, we'll be going for IPv6. Why we have IPv6? This is the inter question. We have IPv4. We are having 400 crores of IPv4 address. Why should we have IPv6? Why should we have IPv6 means due to the shortage of IPv4 address. In case we have any shortage, we can go for IPv6. After like when we come to internet and all, we need lot of IP addresses. But only 400 crore is not sufficient. So we have moved into IPv6 address. This IPv6 address is 128-bit address. So this IPv6 is hexadecimal format. It contains numbers and letters. It is going to contain both numbers and letters. But in case of IPv4 address, it is containing only numbers, as I told. See, it is a decimal representation. It contains only numbers. But in IPv6, it's going to contain numbers and letters both. So in case of IPv6, this is divided into 8 sections. Divided into 8 sections, and each section contains 16 bits. It is going to contain 16 bits, but here we had only 8. But here we are having 16 bits. So, and it is 128-bit address also, I told in the beginning itself. And the maximum address in IPv6 is 2 power 128. So 2 power 128 means this is the amount of IP address present in IPv6. We cannot tell it is so we have so a lot of numbers here, right? 3402822 366 920 so on. So this many address is present in case of IPv6. And in case of IPv6, it is a column representation. Column representation. And example, I'll take like 2001 colon 000 is 2. So it contains both numbers and letters. So I'll take numbers also example. A B C D is 2. 1 2 3 4 is 2. 12 capital A capital C is 2. 4 5 capital A D double colon 7 A 8 B. So you can see it is divided into 8 sections. 1 2 3 4 5 6 7. I'll take one more. 1 2 3 4. See, divided in 1 2 3 4 5 6 7 8. So I have divided into 8 sections. Each section is going to contain 16 bits. So this one will have 16 bits. This one will have 16 bits. 16 16 16 16 16 16 will be 128 bits. So here each section was having 8 bits, but here each section will have 4 4 4 4. I'll just show you guys. This one will have 4. This one will have 4. So each section will have, each value will have 4. This will have 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. So how much total? So how many bits we are having totally?
32,
Huh?
4. Adding, right?
Yeah, we are adding
128.
completely. Complete
120.
128, right? Yeah. So I told you it's a 128-bit address divided into 8 sections. 1, 2, 3, 4, 5, 6, 7, 8 sections. And each section is going to have 16, 16 bits. Here it's having 16, 16, 16, 16, 16, 16, 16, 16. So total is 128. And next point. It is a colon representation. Okay, next. IPv6 IPv6 was the permanent permanent solution for IPv4 shortage problem. You guys are clear with IPv4 and IPv6, I guess. So next we'll be going for conversions. Binary to hexadecimal conversion. So binary table of 4 bits. So this is the possibilities. 16. How we got 16 here? So this is the IPv4. You can see here. In IPv4, how many we have? Sorry, oh, not IPv4. So this is a conversion. So this is the next topic we're studying. So next conversion, binary to hexadecimal. So binary table of 4 bits. So we are going to create a binary table. So these are the values. Okay, 1. So 1 into 2 is 2. 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is how much?
16.
16, right? 8 into 2 is 16. 16 into 2 is
32.
32.
36.
32.
Other
So 32 into 2,
64.
34.
so 64 into 2
128.
is
28.
128. So this is the, see, we are having 4 zeros. How did we get 0 here? We don't have any value here. So first, how to creating a binary table, first just understand this concept. So how we can create this binary table? So here 0 0 0 0, we got 0 only, because in this values creating a binary table we don't have any kind of 0, so this became 0 only. And next we want the value as 1. How we are going to get 1 here? Here we are having 1. You guys are getting or no? What I'm telling concept, because this is a mathematical thing. Hmm? Not getting.
Can you explain me once more?
Yeah, 1 second.
Hello?
One second, one second. I'll try to explain in Notepad itself. Go to this. So as I told, first it is 1, 1, comma. Next 1 into 2 will be 2. Okay. So 1 into 2 is 2. Why it's getting this? Copy paste. Okay. So I told this is the binary table. How we are going to first we are taking first 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This is the first 8 bits. So the binary to hexadecimal we are going to convert. This is the binary and we are converting into the hexadecimal. So these are the first 8 values. So now I want to get these values. So now I want to get 0 as my value. This is the binary. Binary, it should get converted into the hexadecimal. So these are the values 0. First I have to get 0. Then I have to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We can go up to 14, 15 also. First, how to write this value? First understand this thing. So I want to get 0. So here 0, 0, 0, 0. I want to get value as 0. So you can see in this table, we don't have anywhere as, okay. In this table you can see nowhere is 0. So we'll get as 0 itself. Again, it is in 0. Next we have to get value as 1. How we are going to get value? First value. The value 1 it will come in the first place. Rest all will become 0. That is 1. Again come to next. I want to get the output as 2. So here I have 2. So I want to get output as 2. So here I have 2. So this 1, 2, 3, 4, 4 zeros. This is 1, one's place, and this second place will become 2. Next, I want to get 3. My output as 3. 1, 2, 3, 4 I have. So 1 plus 2 will become 3. So here this 0 will become 1. This 0 will become 1. Rest all will be 0. Output is 3. So I want to get the output as 4. How I'm going to get 4? Here only I'm having directly 4. So I'm having 1, 2, 3, 4. I'm having 4 zeros. This is 1 it finished. This is the second, and I'll get 3 from these both. So what is the output? That will become 1. Rest will become 0. Now I want to get 4. How I'm going to get 4? How I'm going to get 4?
Directly for
Huh?
the third one
Here
is four
already
only.
third one already I'm having 4. So this will become 4. That will become as 1. Rest will become 0. I'm getting output as 4. Next 5. How I'm going to get 5? 4
Four.
plus 1 will become 5. So this, which place? This third place. This will become 1 and this will become 1. Rest all will become 0. Then this is 5. Next 6. You can see here 4, 5, 6. So this both values. So this will become, last value is 0, last value is 0, middle one 4, 5. So this 4, 5, 6. It become, the output will be 6. Again next, how I'm going to get 7? 4, 5, 6, 7. Last three things will become 0, and sorry, last three numbers will be 1, because 4, 5, 6, 7. Last number is 0. This will be 0. This three numbers will become 1. Next, I want to get output as 8. So I am already having 8. Last number will become, this number will be 1. Rest other three numbers will be 8. Next, I want to get 9. How I'm going to get 9? 8. 8 plus 1 will be 9. So this first and last number will become 1. Rest in the middle two numbers will become 0. That number will be the 9. Next I want to get 10. So 8, 9, 10. Add this 8 plus 2 will become 10. 8 and 2 will become 1. 4 and 1 will become 0. Then that is 10. Next 11. So 8, 9, 10, 11, 12. This will become 12. So 8, 9, 10, 11. So leave this 4 will become 0. Then this 8, 9, this 10 will become 1, 1, 1. Next, I want to get 11. Same process. How I'm going to get 11? Here 8 and 2 and 1 will become 11. I told already. Then how I'm going to get 12? 8, 9, 10, 11, 12. I'm adding this both. This both will become 1, 1, and 2 and 1 will become 0. Then I'm going to get 12. Next, how I'm going to get 13? So 8, 9, 10, 11, 12, 13. This 2 will become 0. Rest other numbers will become 1. So I'm going to get 13. So up to 9 numbers I'll call 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This 10 we call as A. 11 as B. 12 as C. 13 as D. 14 as E. 15 as F. We have only up to F. We consider only till 15. You guys got this thing, concept? So from tomorrow I'll be
Yes.
giving you guys some task like you have to do and you have to tell me. I'll be giving conversions to from tomorrow. So this is the conversion from binary to hexadecimal. This is the binary and this is the hexadecimal. We converted binary to hexadecimal. You guys got difference between IP address, basics of subnetting and all. Then we have IPv4 will be differentiating into classes, all those things. We'll start it from tomorrow. If you guys are having any doubts for today's class, let me know. I can clear it now. Any doubts? If you know doubts, you can leave the class. I'll share the notes in the group.